The program here, I've got a couple things that's going to happen. The first one is I have to announce that we are running our parallel swathing lab tomorrow. That's our plan. I've been watching the weather. Looks like that front's coming in later tomorrow night than earlier in the day. So, and then the weather's supposed to get cruddy after that, and I don't want to get caught short on Tuesdays on when we run the lab. So we're going to go ahead and try to push that through tomorrow, and I've got to give you some background on that, which I'll do today, and then 2:10 in the lab is when we're meeting, and we've got to run out there and get it all done, hopefully at that point. I'm hoping, my plan is to have everybody drive with the light bar. That many in class, it could be a little bit of problematic, but if anybody has any problems driving that little gator around, it's pretty easy. It's fine, actually. Let me know, but my goal is to have, everybody's going to work in pairs. The concept is we'll have two people drive together, and then the thought would be at some point in the middle, we'll just have you guys switch. And then try to read the light bar. Got it. Okay. I do need to talk about light bars, but before I get into that, I want to ask to see if there's any questions. You guys working on the lab assignment due on Wednesday right now. Control system response, 3 different response rates or gains, looking at time constants and response times. Hope everything's
How do you want us to turn it in? You just want the values because there's so much data on it.
Don't need the data. A couple of plots. Of course, the graphs I've asked you for. Table typically would be best. Here's my response rates. Here's my response time and time constant for fast, medium, and slow response rates for pressure. And maybe do the same thing with flow. GPM as opposed to pressure. Okay, so first thing I want to announce is the Russians are coming on board with GLONASS, and people say, well, how does that affect us? They're launching satellites. They were down to like 8, and as Ezra mentioned, they're up in the 20s now. They hope to have a full constellation by 2012, I think. 11 more GLONASS M satellites will be launched by the end of 2012. And so they're getting a lot of satellites up there. The reason that that's important or interesting for us is that most of our receivers, the Garmin units, my Trimble unit, a lot of the units only use Navstar satellites. However, a lot of them are starting to use both GLONASS satellites. And I'm going to show you the influence of that probably right now. Let's get time to lead into that. The concept would be, this is what's happening here. We have GLONASS, where a lot of the older satellites only had a 3-year design life, and they would stop working. And then they launched a bunch of them. And so now in 2009, 2010, 2013, they decided they're going to redesign and start launching them. So that's what they're working on right now. Now, what's the importance of that? Why is that important? That actually feeds into guidance systems, but also feeds into, and I'm going to shoot over here right now, this concept of mission planning. Because when you go out and you're trying to get good satellites for a position, you need to make sure that the satellites are available. And then those who have taken 555 have probably already seen this concept of mission planning. But this is a Trimble product that would come out, and it would talk about how many satellites are available to you in different modes. Right now, you can see on satellite systems, I just have GPS set up, and I'm only going to be looking for GPS set. Oh, come on. And one of the things I have to do is do a file and do my station. Where am I located, and what time am I looking for satellites? Right now, I've put in Knoxville. You can actually click on, this is a free download off the Trimble site. I believe it's also on my site too, the Blackboard site for the class. And you can either find your city or put in your latitude and longitude for your position. You have a height and an elevation cutoff, meaning how high do I want my satellite. I'm not going to be able to see satellites that are 0 elevation, but I need to have some sort of elevation angle. So that's 10 degree mask cutoff. I can't see any satellites below 10 degrees. I'm actually pretty shallow, if you think about it. I will have a start date, which is the 31st, and I can change that to today. Start time, 0 to 24 hours. So this is like for a whole day, where are my satellites and what's going to be available. And this is in 10-minute intervals. I put in my Eastern Standard Time and change my time zone. So here I'm inputting where am I and what time am I looking for satellites. So I hit OK. Then there's all these different things up here that you can click, like where are the satellites in terms of elevation from 0 to 24, and these are all the different satellites that are up there, and how high are they in the sky. Okay. This is a very handy one here. This deals with, what satellites are visible to me as I go out and look. So from midnight to midnight, wow, there's 8 satellites available. That's usually pretty good. Maybe drops down to 7 here, 8 here. Ooh, this is a little bit bad. Maybe dropping down to 6 satellites for a short period of time at that point. However, if I'm out in the field and I want to look at, like if I'm in the Big South Fork in a canyon and I've got a pretty significant elevation mass because I'm in a gorge, then I can go in and change this and say, okay, I'm going to change this cutoff angle from 10 degrees to 30 degrees. Say we're down at Obed Junction, right? And we're trying to figure out whether we get satellites, and I hit apply and hit OK, I guess. And here we are. And now the problem is, well, look what's happening right here. Here I'm down to 3 satellites because I've changed my mask angle. And if I go back to DOP, I think my DOPs are right here, dilutions of precision. You can see that my DOPs go sky high, right, in that range. And so my DOPs are pretty high. Now, I haven't figured out how to change this yet, but I'm really more concerned with HDOP, my horizontal dilution of precision. They throw all the DOPs in there, and there's probably a way to change that. Anybody know how to change that where I'm just plotting HDOP?
Oh, there's a function that should just plot. We'll give you an HDOP, I think.
You should be able to plot each one individually.
Yeah, it should. It should have an
Okay, so
individual.
that would be under...
Just go back to lit or options or graphs or.
Okay. Toolbar, agenda...
No, lit or go to.
List. Dot values. Hyperpage. This would be DOPs at different times. So, yeah, I guess I could look at this and see what my DOPs are. And so if my HDOPs are real high...
What was the interval you wanted, like 3? What was the value you want?
For HDOP, typically between 1 and 3 is good. You know, if you got 0.9, that's even better. You know, that's probably the best I've ever seen is 0.9. In theory, your positional accuracy is your HDOP times your pseudo-range accuracy. Pseudo-range is how much can I measure the distance to the satellites, my pseudo-range measurement, and I multiply that by my HDOP, and that typically gives me my positional accuracy. So if it's up around 3, and my pseudo-range error is 1 meter on average, then typically my positional error, latitude and longitude, is 3 meters. Now you got to watch out because some of the GPS units will say, well, if the HDOP is greater than 3, don't output a GPS signal. I want to know where I am, you know, when I'm out in the field. So I typically store which string, which has HDOP on it. GGA, close. My favorite string, the GGA string has HDOP on it. And so that's why, so that's what I store there. So that's important. Now, the concept would be, and I don't know if I can do this on the fly, but let's just try it. What happens if I include my GLONASS satellites in there? And now you can see my my DOPs drop dramatically. And my satellite availability is pretty high, right? So I'm still at the 30-degree mask angle, and now I've added both GPS and GLONASS